Hi, how are you all? Today we are going to start with the last two theorems of the first chapter, that is the real numbers. These theorems are again related to the actually terminating and non-terminating decimal representation. Okay. Suppose a number is given to you, that is 4 upon 25. Obviously we could say that yes, it is a terminating decimal. How we can say that? Because let us first read what is the theorem given to you. The theorem was given: if x with a rational number whose decimal representation terminates and can be expressed in the form of p upon q, where p and q are the co-primes and prime factorization of that q is of the form 2 raised to n, 5 raised to m, where n and m are the non-negative integers. That means our denominator should be expressed in a prime factors of 2 and 5's. Okay. So here you will say, sir, there is no 2's. Okay, but still we can say that a prime factorization of 25 is of the form 2 raised to 0 and 5 raised to 2. I hope you understood what I mean to say. You need to express always in this form. Okay. Let us take some another example. Like example is 31 upon 455. Now you need to prime factorize first this 455. So we are going to factorize it. That is 5. 5 9s are 45, 5 1s are. Okay. Then it is divisible by 7 because it comes in a table. Like 7 1s are and 2 will be left, 7 3s are, so 30. So here prime factorization of 455 is 5 raised to 1, 7 raised to 1, 13 raised to 1. It is not of the form 2 raised to n and 5 raised to n. Hence, it doesn't have that decimal representation, right? This is what concept you have to keep in mind whenever you get any fraction like this. Okay, suppose if I get a number 16 upon 3125. So what I am going to do? I am going to do a prime factorization of that 3125, and then we will see. So here 5 6 are 30, 5 2s are 10, 5 5s are 25, then 5 125, 5 25, 5 5 and 5 1. So here I can write down prime factorization of 3125 is of the order 2 raised to 0, 1 2 3 4 5, right? So that is 5 raised to 5. Therefore it has terminating decimal representation. Okay, that is the way how they are going to ask a simple question based on that are nothing but whether it is terminating or not. And sometimes they ask you the question which are related to this topic but in a different way, like after how many decimal it will terminate. Okay. Now for that, let us go to the basics. If you remember, this is, we have written this way, 2 raised to 1, 5 raised to 1, correct? So it is decimal up to how many places? Actually it is 0.1. So decimal is 1 place. Okay. 1 upon 100, that is 1 upon 2 raised to 2, 5 raised to 2, 0.02. Decimal 1 place, decimal 2 places. Okay. 1 upon, if I write down 1000, that is 2 raised to 3 and 5 raised to 3. So it is nothing but 0.001. So if there are the 3 zeros, you can write down. So depending upon this particular number. So any decimal representation you need to know, then we can write down this way. Now you will ask me the question, sir, how we are going to write down this other decimal representation. So for that, 4 upon 25, we can write down it as 4, 5 raised to 2 into 2 raised to 2 and 2 raised to 2. Either you can write down this as our next step is equal to 4, 5 raised to 2. So I want also 2 raised to 2. So into 2 raised to 2. So how much you will get this? 4 into 4 upon 100, right? So that becomes 16 upon 100. So it becomes 0.16. So after the 2 decimal places, it will terminate. So that is the way how we are going to solve the problem based on this particular exercise. They will give you the any damn number fraction. What is your first step? You try to prime factorize the denominator, check whether it is becoming in this particular form. If there are the factors other than 2 and 5, 7 is there, 11 is there, 3 is there, definitely it is non-terminating. Okay, because if in denominator we get 3, denominator we get 7, denominator we get 9, denominator we get 11, 13 and so on, so we will get there as a recurring number which is not going to terminate for that particular decimal, right? So that is a concept you have to keep in mind. Actually theorem 1.6 is also mentioned in your textbook, which is a exact converse, means opposite of the theorem 1.5. Here we are saying just ulta. X is equal to p upon q can be a rational number such that prime factorization of q is 2 raised to n, 5 raised to n, then it terminates. Here what we say, x is a rational number which shows a decimal representation terminates, then q will be having the factor of the form 2 raised to n and 5 raised to n. So that is about your the whole concept of the chapter, right? Now in textbook they have given, in that last exercise they have given the question based on that particular topic, and these are of the same kind. So what is your main and important point in that calculation is that first you show the prime factorization of the denominator and check whether it consisting of the 2 and 5s or not. If it is not consisting of 2 and 5s only, then it is not decimal. But if it is 2 and 5 is there, then definitely it will be an decimal, right? So that is the way how we can write down about the problem. We can solve the problem based on that theorem 1.5 and 1.6. In this way your the chapter first of the real numbers is over. Now you try to solve the exercise based on that. I will give the extra question in our the PDF form or either in our Google documents. So you try to work on them and make a comment if you had any problem in that particular chapter, right? And we will be taking shortly your test. We will take obviously the online test, because since the COVID is going on, we are having some restrictions, so we can have a test on that. If you need more question based on any exercise, you just let me know so we can go ahead with that, right? And this video, just I make a sure that 1.5 and 1.6 is over, is covered, and your the last exercise will be also you are able to solve it properly, right? So you try to again have the look on the board, or you can take the screenshot if you can, so you can get the idea how we started with prime factorization of denominator everywhere. This is a key success for that particular two theorems whenever we are going to use. And if they are asking the question how many decimal places after that, right? So that also answer you will get by that decimal factorization and by that numbers, right?